Hi, my name is Susie Coker. I'm an extension forester for the University of California Cooperative Extension in the Central Sierra Nevada, and that covers El Dorado, Amador, Calaveras, and Tuolumne County. We've had a lot of bark beetle-induced mortality in this area. Trees have been dying, and so we've put together this set of ideas and advice on how master gardeners in this area and around the Sierra Nevada can advise people on what to plant next. So that's what I'm going to talk to you about this morning. The goals of my presentation are to give you a little background on the drought in the Sierra, why it's happening, what exactly has been happening, and what we can do about it. What we can do about it depends a lot on the scale that we're talking about. The forest at the landscape scale has a few options for treatment to help avoid bark beetle mortality and also for reforestation. But around the neighborhood, the scale is really quite different. We have a lot of people in amongst the forest. We have homes, we have very small parcels. And so the advice that I'm giving you in this presentation is about what you can do at that smaller scale and what we would recommend. So just a little bit of background about this big bark beetle outbreak. It's really unprecedented, and it's due to a very difficult conditions in the Sierra Nevada forest, in the ponderosa pine and the mixed conifer zones. Basically, we've had about 100 years of fire suppression in our forests, which have led to overcrowding. In the past, our forests had wildfire that came through in a lot of areas in the Sierra Nevada every 10 years or so, higher elevations maybe every 20. This was caused by lightning and also Native Americans that were actively burning in order to manage the forest, manage the undergrowth, and basically promote growth of oaks and acorns, which were the staple crop, as well as help out with hunting and a number of other reasons. About 100 years ago, we decided that fire in the forest was a bad idea, and so we suppressed all fire, which meant that when a fire comes through, there's a lot more material on the ground, a lot more fuel because it burns rarely, and also a lot more trees. So the trees are more crowded in their where they're in their stands. They have less soil moisture, and so in general they're less healthy. It's a lot like a gardener would experience when they overplant seeds in a garden. A lot of our instructions on seed packets are to plant densely and then thin out as we see how the germination goes. And it's very similar in a forest condition. A lot of seeds come down, and our forests here in the Sierra Nevada evolved by constant thinning through frequent low severity wildfires. So since we've stopped doing that, we have a forest ecosystem that's very overcrowded and also less healthy. In neighborhoods as well, people generally like to have a lot of vegetation, especially for screening between homes, and it seems that homeowners want to keep more trees on the landscape around them than might be really sustainable from a natural capacity of the landscape and the soil moisture that's there. So we have that factor going on, and then we have this amazing drought that we've had for 4 years between 2012 and 2016. And that drought was also unprecedented in scale, and it was also a very warm drought with climate warming. We have more moisture stress because plants are warmer and they are metabolizing. They need more moisture, not less. And so a warm drought causes additional stress on trees. Trees can defend themselves from bark beetles in the best conditions, but with this kind of 1-2 punch, there's been a lot of susceptibility in our trees to beetles and just a lot of die-off all around the Sierra Nevada. So here's a little bit of information about the drought. These should look familiar to you if you've been paying attention. For the last 4 years, we had extreme and exceptional drought throughout probably a large part of the state of California. So moisture is important for a lot of physiological processes in trees. There's a new measurement called Canopy water content, which measures the total amount of liquid water in the foliage of canopy. So if we can measure this, then we can get an idea of the progressive drought effects on the individual trees. There was a series of data collection flights by the Carnegie Airborne Observatory that used a number of advanced techniques, including LIDAR, which is light detection and ranging, to try and estimate how much water is normally in the canopy and how much was missing, as a way to measure the stress that the trees are going through individually. So here is an image from Greg Asner in 2015 that shows progressive forest canopy water loss during the California drought. You can see the difference in colors between blue, yellow, and red. The ones in red are experiencing the largest amount of stress. So they're down to ½ a liter per square meter of water in the canopy. The black areas are wildfires, which are different, and so the data was kept out so as not to be confusing. But you can see that the stress and the loss in canopy water content is the highest at the lowest elevations and also in the more southern elevations. So areas like the Southern Sierra have large patches of red, meaning there's a lot of drought stress going on there. And this is a collective measure over that time period, along with a table that shows how much of the forested area actually experienced water loss. So the table is actually in millions of hectares. A hectare is 2.5 acres. So if you multiply by 2.5, you would get an acre. On the right, on the bottom of the scale, that shows you how much of the canopy water loss occurred in a certain area. So that 0 to 10% column, that's where 10% of the canopy water was missing over that period of the drought. All the way to the right, you've got 40 or 50% of the canopy water content missing as a result of the drought. So on that top line, you can see there's 5 million hectares, or times 2.5 would be about 12.5 million acres, where 10% of the water content was missing from the canopy. All the way to the right, where you have areas where over 50% of the water is missing. At the bottom, you have the maximum number of trees affected in millions of trees. So 475 million trees lost 10% of their water. 13.6 million lost up to 50% of their water content. So that's a huge stress on a very large number of trees caused by this drought. This is a slide from a recent study by Derek Young, a student at UC Davis, who looked at where the trees were dying. So those last slides were showing you kind of on a cumulative basis, number of trees in particular, but this was an analysis of where the mortality actually happened. So on the bottom line, you have mean annual climatic water deficit, or that's a measure of stress, drought stress. So the farther you go to the right, the more drought stress you get. And on the left, you have live basal area, square meters per hectare. Basically, it's a measure that foresters use of density. So the more the basal area, the more trees there are in a particular area. So you have crowding on the vertical axis, and you have drought on the horizontal axis. And what you are meant to notice here is that the mortality is really accumulated in areas where it's dense and dry. At the so the observed mortality is on the right. If you look, you can see that some areas were very, very drought stressed at the bottom of the graph, up to 1,000 millimeters of climatic water deficit. That's 3 feet of water. But you don't see that much mortality. Mostly you see green until you start to go up the scale where things are much denser. So you could experience a lot of climatic water deficit, but if the density is very low, you had low mortality. And that's what these figures are showing. So they were really able to show that the mortality was focused in the driest areas that were also the most dense, which makes sense from a physiological standpoint, as we understand how trees fight off bark beetles. Okay, so here is an overall progression of mortality of trees in California on 3 of the years of the drought. 2016 was the year with the most drought mortality. And this is data that was put together by the Forest Service, their aerial detection monitoring. So basically they flew in small planes over the forest and mapped areas where they could see a lot of dead trees. So the darker the color, the more dead trees per acre were seen in these detection surveys. In 2014, you can see starting some mortality throughout the Sierra Nevada. 15, it's starting to ramp up, and in 16, you see large areas of dead trees as the drought progressed and the drought stress accumulated over time. So it's been a very, very large event, basically unprecedented in the Sierra Nevada. They also observed in 2016, there's the, the cumulative observation and a forecast for 2017 based on what they had seen in January and February for snowfall and moisture accumulation. So we're doing this workshop in 2017. We don't know how close that's going to be to what is actually observed. So I guess stay tuned to see how well that panned out. All right. I think I mentioned this a little bit already, but what we can do to prevent mortality really depends on the scale. At the forest scale, there's not a lot that can be done outside of just proper forest management, having species that are adapted to the site, native species, and a nice mix, since, as you'll learn from other presenters, bark beetles are specific to species. So if you have a number of species on the site and one bark beetle gets out of control, that doesn't necessarily kill everything, as it would in some areas that have more of a monoculture, like Colorado or British Columbia, where it's lodgepole pine everywhere. And so a mountain pine beetle can really get going and kill trees throughout a really large area. So our mixed conifer species is a protecting factor for us, making sure that our forests are thinned so the trees are individually healthy, and also that wildfires can thin areas or prescribe burning as well. However you do it, keeping a less dense canopy out there is one of the keys in the forested areas. Around your neighborhood and around your home, you have a few more things that you could do. And in addition to having plant species adapted to the site, you can make sure you take care of your trees. Around your home, potentially you can water. You can thin to the appropriate density, and there are some pesticides that you can use for a few high-value trees around your home. But it does get expensive, so it's not something you'll be doing on large scale or large areas. And I believe another one of our presenters is going to discuss that. So I'm going to move on to talk about what to do after you have trees die and after you have trees that are removed from your site. These are species specific to the Sierra Nevada, but common throughout the areas on the west slope where homes, neighborhoods, and communities have lost a lot of trees. If you look at the picture, you'll see a typical site. There is ponderosa pines that died that were the trees in the overstory or the top layer. And then the trees in the understory, in this case, incense cedars, have survived this tree mortality bark beetle outbreak. So the ponderosa pines are really the ones that have been hit by western pine beetle. So we've been seeing a lot of mortality in some parts of the Sierra Nevada range, up to 90% mortality. But that doesn't necessarily mean that there's not something already growing underneath. Basically, we have shade tolerant and shade intolerant conifers, and so pines are shade intolerant. You often find them growing in the overstory, that higher canopy. They grow very quickly, and then other trees can grow underneath them because they can handle the shade of the pines. A lot of times you cannot see young pine trees growing in the shade because they are not tolerant to it. So it's very rare to see young pines under large pines. And what you have under there is the shade tolerant species. That's the incense cedar and the white fir. Sugar pine and Douglas fir are kind of intermediate in their tolerance for shade, and so you may find them in clumpy areas. They may have done just fine in the drought, although we've seen quite a few sugar pines being hit by mountain pine beetle. The other thing that seems to be doing well in the understory as the overstory of pines dies off are oaks. And they seem to be taking over where other trees have been removed. They can, if they get knocked over during a tree removal process, they can sprout back from the stump. And so they seem to be favored in a lot of locations as a lot of these trees are dying off. Okay, so like in my last picture, you know, in this case, you have cedar growing back. If that was your yard, you might want to preserve your cedar. Those are pretty large ones. This is perhaps a little bit more common. Here's a little opening with trees around it. You might have this still left in your yard or near your house. And so you could, rather than needing to replant, nurture these existing trees. So you would have perhaps these clumps of small trees. One thing you can do is thin them out so that they have plenty of growing space. Oftentimes now that the trees died off above them, they'll be getting more sunshine, and they haven't been used to that. So I think watering them a little bit in the first season or two to help them with that extra solar stress that they're not used to could be very helpful. And as shrubs grow in and other plants take advantage of these newly sunny sites, it's important to favor the trees by clearing out these competing shrubs and grass and other vegetation. A lot of homeowners ask me about digging up natural seedlings and moving them around to places. It's not something I would necessarily recommend doing. You could put a lot of effort into it and get a low return. You need to do a really good job with digging up the roots, and then they would need to be watered afterwards. So in most cases, I would start over with new seedlings. It has been done successfully in a few cases, but it takes a lot of care and nurturing. So if it were me, I would start over with brand new seedlings, if needed. In this case, it doesn't look like you would need them in this picture. Okay, one thing that people have been asking me is about pines. People are concerned if a lot of their ponderosa pines died, that means ponderosa pines are no longer useful on this site. Or they may be concerned that if they plant them, they'll be killed by the beetles the same year. Or they may be concerned that they're setting themselves up for spending a lot of money taking them out later because they're no longer adapted to the site. And our best guess to answer this really is that pines really are well suited to the Sierra Nevada. They're actually our most drought tolerant tree. You know, that sounds odd because they're the ones dying in the droughts right now, but in general, they're more drought tolerant than a lot of their competitors, and also they're more fire tolerant. Firs and cedars are one smaller, at least, less tolerant to fire. And so there's a good case to be made that the most resilient forest that you could have in your area would have a large proportion of pines in it in the future. Also, they're a native tree, and they're well adapted to the local climate. They've been in the Sierra Nevada for thousands of years. Young trees also are not typically susceptible to bark beetles. Somewhere between 4 and 5 inches is how big around a tree needs to get in diameter before a bark beetle is interested in it. So even if the bark beetle epidemic was continuing, which it doesn't appear that it is here in 2017, you would not be necessarily losing young trees as you're planting them because they're too small for the beetles to attack. So there's not enough for them to eat. So usually your young trees will have a couple of years at least of just natural defense in that way. Also, as I described before, pines may not regenerate well on their own because they're shade intolerant, so they're not going to be found in a lot of understory areas under the large pines just because of the conditions there. So if you had nothing but cedar, if it were me, I would plant some nice little pines there and try and put back that component of the native forest around my home or neighborhood. People do ask about climate change, and I do think climate change is a factor in our current drought and a lot of the mortality that happened. It was a very warm drought, and we'll have more warm droughts in the future. So yes, climate and climate change is a factor. So yes, there may be some areas where pines are not ideal for the future. Things like areas that may be the farthest south in the Sierra Nevada or the very lowest elevations. If you're on a south-facing slope at low elevation, just, when there barely were any ponderosa pines, perhaps it's not a good idea, and you could just favor the oaks in that area. But in general, there's still plenty of great places to replant our ponderosa pines, and please don't just give up on them. I think they have a good future in the Sierra. Okay, so that said, what kind of plant material makes sense? Around a home or neighborhood, you may want some larger trees that you buy from a nursery, and homeowners generally want to put these in their most important locations to create visual screening or windbreaks. Here's a neighborhood planting with a larger aspen in a visually important location. Because they're more expensive, they require ongoing maintenance, watering the first couple of summers. You can't probably plant a lot of them, so put them in the most important places. They also would benefit from soil amendments, compost, or other additives that maintain the soil moisture. Here on the left are some container-grown seedlings. They're much less expensive to purchase, maybe $1 or $2 a piece instead of, $100 to $200 a piece. And so you can get a lot more of them and cover larger areas. They may require some care, including watering in the dry season, and you want to plant them in the early spring or late fall when there's the highest moisture. But generally these work great. They're grown in a nursery in little soil containers. That's what you're seeing there. So you can just pop them right out of there, put them in the ground, and cover large areas. An even less expensive option is the bare root option that comes from a tree nursery. And those definitely need to be planted at specific periods, early spring or late fall. But they are the least expensive option. You can often get them for $1 or less a tree, and so they are the most make the most sense on large acreages. Here's an oak, and it has very deep roots, so they can be transplanted from containers. That can be expensive to get a large enough one. Another strategy you could do is by planting acorns that are gathered locally in the fall. That's very inexpensive and can have really good germination if done right. Okay, so that's what species to plant and some choices of plant material. I think the last really important point I want to make is just that around your home, you need to make sure to think through where you're putting trees for the long term. Defensible space is really important. You're going to be starting over with your landscape in some places, and so getting it right from the beginning saves you a lot of future headache. Um, you want to plant trees with appropriate spacing. That depends on where you are and the tree type, but you'd want them at least 10 feet apart. Don't be tempted to overplant because they're so small. Make sure you look at if you're getting a landscape plant, look at and read the label and make sure you understand how big it will get in your location before overplanting. Defensible space. You don't really want a lot of flammable vegetation close to your home, especially not within the first 5 feet. That could be a great place where you have just non-combustible material or very well irrigated herbaceous material. Definitely not woody shrubs within 5 feet of your home. A few individual trees within that 30 feet is good, and from the 30 feet to 100 feet zone, they should be widely spaced so that the crowns don't touch when they're mature. After that 100-foot zone is considered the more natural forest zone. These are some of the requirements of our Public Resource Code 4291 on defensible space around your home. It is up to interpretation by each local CAL FIRE and forest fire department. And so my number one advice would be just to work with your local fire department to get their interpretation. But definitely please think about this as you're planting those trees. Power line clearance is very important as well. You don't want to get too close to them and develop trees that end up having to be topped every couple of years and tortured. Please avoid torture in the future by not putting them there. You want to keep them out of the road right of way. And you want to also think about the sun availability now. So pines where there's a lot of sun, you might want to assess, where you're putting them, what kind of shadow you can cast if you think you're doing solar in the near future. And then views, of course. So I've definitely done planting projects where people felt good about planting the trees and then maybe thought more about that later and decided they needed to take some of their new trees out in areas that were blocking their new views. With all that vegetation gone from those dead trees, you may have some really great views. So please keep those in mind as well when you're planting so that you can hold on to those. Okay, that's my main message to you. And we have a lot of other great presenters in this series for Master Gardeners. So they're going to go into a lot more detail about bark beetles, forest succession, and what kind of assistance programs may be available for landowners for reforestation. So I just want to thanks for helping us get the message out and for being a Master Gardener volunteer and helping the public with their tree mortality questions. So let us know if there's anything else that you need. And if you have a question, please feel free to contact me at this address and I will try and help out with whatever question you've been asked. So thank you very much.